Welcome to qnawire.
So I believe it's very helpful to draw a free body diagram of this boat. We have a boat, force of gravity, the buoyancy force, and it's saying that the water is just at the top of the boat. So essentially, the entire volume of the boat equals the volume of the water that is being displaced in this scenario. And we know that the boat must float, which means that the sum of forces in the y direction must equal 0, which means that the force of the buoyancy force of the water minus the force of gravity must equal 0. The buoyancy force must equal the force of gravity of this boat. So solving for this, we have the buoyancy force, so the volume of water, times the density of water, which will give us the mass, times the acceleration due to gravity equals mg. We have a mass here, and we need a volume. So volume here, we cancel out gravity, and we find that the volume of the water, which does equal the volume of the boat, is going to equal the mass divided by the density of water. Here, this is going to be 5,750 kilograms divided by 1,000 kilograms per meter cubed. So this will be, the volume of the boat is going to be rather 5.75 meters cubed. And so this is the volume of the boat, given that it's just given that the water is just at the top of the boat. In order to solve, and now the captain must throw cargo off the ship in order for 20% of that volume to be 20% of the volume to be above water. So here we're going to rewrite this equation, and we're going to say that this is part A. So part B. So part B will be the mass times gravity, so the weight of the boat, must equal 0.2 times the volume times the density of the water times the acceleration due to gravity. The gravity, of course, cancels out, and the mass that we are looking for is simply 0.2 times the volume of water that's being displaced times the density of water. And solving for this, we have 0.2 times the volume of the water is going to be, again, 5.75 meters cubed, and then times the density of the water, 1,000 kilograms per meter cubed. So, and this, solving this out, we have 1,150 kilograms. So this is the final answer. This is how much weight, this is how much the mass of the cargo that must be thrown overboard in order for the boat, for 20% of the boat's volume to be above water. And then this is the volume of water that is displaced, given that the boat is given that the boat is barely floating and the water is just at the surface level of the boat. And that's the end of the solution. Thank you for watching.